I'd like to welcome you all to the Applied Analytical Chemistry course, the CHEM 211. My name is Samuel Mugo. I'll be the instructor for this course. The best way to get hold of me is through the email, which is indicated here, and my office number is 5-131C. Of course, because of the pandemic issues, while I'll be available in the office, most of the lecture component in this course is gonna be online. But of course, you can get hold of me also in the lab as well. But, we're gonna be doing this mainly online. And so if at all you've got questions, and so forth, we're gonna use the online platform, which is a Blackboard Collaborate, for any questions. In this lecture, short introductory lecture, mainly help you familiarize, with supposedly what you got yourself into, course expectations, and so on. And so I'm gonna keep it fairly short, for the next 20-25 minutes or so. Now, the textbook resource that we're going to be using in the Chem 211 is a so-called quantitative chemical analysis by Daniel Harris. There are different types of editions. Well, I won't require you to buy the textbook, but most of my lecture notes are going to be taken primarily from those textbooks. Maybe 70% of it is going to come from these textbooks, and the rest is going to come from other different sources. As I've said, yes, I do not require you to buy the textbook at all. The notes that I provide are largely satisfactory for you guys to do very well. But if any reason you want to refer to the textbooks and you don't have a copy, I can lend you one. I've got several copies in my office, so you can borrow some on a short loan and then you return it. However, as I said, the notes are gonna be largely satisfactory, but of course, if at all you want to go much more in depth and refer to the textbook yourself, as I said, you can borrow one from me. Of course, if at all you got excess money, you can as well go buy the textbook, but I do not mandate you to buy the textbook. So what did you get yourself into? I hope, this introductory lecture again is gonna highlight the course expectations and calm your nerves and hopefully get you excited about the course. First and foremost, I would like to state that my classes are a safe space. Everyone is valued. Everyone is respected. Your voice counts. And as such, I would expect you guys to really engage with me as your instructor. I call myself as your mentor, as your coach. But also, to create an environment, that is engaging for each one of us so that we can learn from each other. And so let's make it, a fun time of engagement, back and forth. As I say, there's no dumb question for you to ask. If at all you've got anything that is unclear and you want me to help you in that, certainly, shoot me an email and I can help you, in addressing, your questions. So my teaching philosophy is, to hopefully help you see the interconnectedness of analytical chemistry to the broader society. And so my teaching philosophy really is to reveal the connectedness or the interlink between analytical chemistry and life, and society. So chemistry is really intricately connected with society, and I hope you guys in this analytical chemistry course, you'll be able to see those connections, and hopefully, by me helping you see those connections, that's gonna help you accelerate your career path. And so it matters to me to see that my students get some clarity on what type of career paths, they're gonna get into. And hopefully, this course, Applied Analytical Chemistry, is gonna help you to some extent in getting you toward that direction. So you're gonna see as I teach, I try to make the course very, very relevant, focusing a lot on the applications of the chemistry or the analytical chemistry content, to different types of careers out there, be it food science, be it environmental analytics, be it medicine, be it engineering even, and so on. You're gonna see there's an element, of analytical chemistry in a diversity, of applications out there. And so as I've said, the focus for this course is application. When you learn a theory, I would like to see you guys apply it, towards solving a problem. And so it's not just the knowing, I really care about making sure that the students can apply whatever they are learning, the theory they are learning into doing. And by doing so, that's the only way you can be in terms of being whatever you want to be in different career paths that you choose. And so knowledge utilization is very important, as my teaching philosophy. It's not just about knowing. The key thing, the industry out there care about, can you utilize the knowledge that you know so that you can innovate, so that you can solve societal, industrial problems that people care about. And that is the crux of analytical chemistry, that we actually teach. And that's going to be the focus really, for most of my lecture content, but also of course, for what you're going to cover in the lab. So I try to draw a lot of interconnectedness between, the lecture component, but also what you guys will be covering in the lab, which is really doing, as I said, so that hopefully that can accelerate your career paths. So maybe very quickly, take a moment, to consider what are your expectations, for this analytical chemistry course. Why are you here? Maybe it's a good thing, to think about that. Why did I invest, whatever amount of money that I paid for my tuition to take this particular course? What do you want out of it? Well, I'm gonna tell you what my expectations for you are, as far as this course is concerned. I like every one of us, to be engaged. As I have mentioned, it's very important for you guys to ask questions. I always say questions such as what if, how, why. None of these questions really, are dumb questions. You get to understand things in a deeper way if you ask these types of questions. And so if I throw some theory with relation to analytical chemistry at you, particularly on instrumentations, always ask yourself, why does things work the way they do? And that way you get to understand, things in a deeper way. And so again, I'm gonna expect those kinds of engaging questions, from you guys, so that you can interrogate, the course content in a deeper way, and hopefully so that you can get a lot more out of this course. Now, my other expectation for you is to appreciate, hopefully, analytical chemistry and its relationship to the community and the real world around us. How does analytical chemistry apply to the real world, particularly in solving challenges, that people care about? So you're going to hear me talking a lot about analytical chemistry and how we can solve the so-called United Nations Sustainable Development Goals. There are 17 of them, and they are global challenges, which are the core, of what analytical chemistry, can actually solve. And if you're able actually, to situate yourself in a place where you're thinking of the knowledge that you're learning and how it can apply into solving these global challenges, I can assure you that you won't have a problem, in terms of finding a meaningful purpose for work, when you finish, your degree. So that's important to me, appreciation of analytical chemistry and its relationship, to the community. And so that's one of my core expectation of you guys, that you're going to appreciate that. And hopefully, you're also going to enjoy or celebrate, the learning process be it from the lectures, from the labs and from more engagement, during the lecture hours, which I'm going to talk a little bit about. It's going to be a little bit different, because of the COVID. The lectures are going to be posted online for you. But as I said, I'm going to make myself available during the designated lecture hours, for your questions, My other expectation is, do not stress out. I do not believe there is anything to be gained, from really being stressed out. And so my goal, is to make things as clear as possible for you. And if something is not clear, just shoot me a question. Don't be stressed about it. Let me know, and I will do my best, to support you, in your learning process. So in the next couple of slides, I'm going to highlight, mainly from the course outline, some of the critical course expectations, particularly related to evaluations and so on, deadlines and so forth. So again, please pull the course outline, and look at all the details of it, sort of as the contract, that's the agreement, between you and I in terms of the course expectations. So keep an eye, on what's expected of you in that course outline. Look at, the student expectations, in relation to, the exam, in relation to ethics, things like plagiarism, what's expected of you. Please take a look at the course outline, which, as I have said, it's really a contract, a binding contract, between you, and I. Now, in this course, we're going to focus, as you're going to see in the course outline, on the variants or different types of classical and instrumental methods of analysis and data analytics. Now, remember, analytical chemistry really is a chemistry of measurement. So we are trying to determine either qualitatively or quantitatively the chemical composition, of some of different types of samples. There could be a urine sample, and you are required, to determine, what's present in the urine sample and how much of it is in there. And typically what you do, you use different types of what you call classical methods of analysis, or you use what you refer to as instrumental methods of analysis, which is what we're going to be talking about in this course. And as such, you're going to generate, a lot of data or measurements, using these types of methods of analysis, classical or instrumental. And so you're going to be trained, or you're going to learn, especially data analytics. How do you make sense out of these data, so that you can relate, the data you get from the instrument to the information that you're looking for, which is often, how much, of a chemical species is present, in a sample. So you do a lot of data analytics. Data analytics really is the basis of what your people are calling artificial intelligence, which is really the future, of digital innovation. So as I said, analytical chemistry really connects a lot, to this whole field, of artificial intelligence, which again, there's lots of career options in that direction. So the skill sets, that you learn in data analytics in this course, are gonna hopefully accelerate, open your eyes to possibilities of different types of careers, you can take that into. Now, this course includes, as I've said in the previous slides, numerous real-world examples of organic/inorganic analysis as they apply, to the contemporary or modern-day industrial applications. Now, in this course also, very important, there will be a term paper. And the term paper, as you're going to see, in the course outline, constitutes quite a significant component, of this course. And the purpose of the term paper is hopefully for the students to learn how to synthesize scientific literature, and also how to write, scientifically, and also, of course, present, the data, you know the data in class, and the whole idea, of course, to help you guys improve, not only your scientific writing, but also the oral presentation or ways of presentation or disseminating your data, in a different type of setting. And so the term paper really, is a critical component of this course, and I'm gonna talk a lot more in detail about that. All term papers, are gonna relate on how analytical chemistry can be used in solving a societal problem. And as I've said, I'm gonna talk a lot more about that later. So the course prerequisite, I assume you're here because you already had a minimum grade of C- in Chemistry 102. And so you're going to see this course covers a lot about chemical equilibrium that you guys covered in Chemistry 102. And my expectation would be that I'm going to be building on what you already know as it relates to different types of chemical equilibrium, that you guys know about, be it acid-base equilibrium, be it complexometric equilibrium, be it phase distribution equilibria, redox equilibria, and so on. So I'm gonna be building on those concepts as they relate to analytical chemistry, which is classical / instrumental methods of analysis. So very quickly, take a look, at the due date, be it for the midterm, which is gonna be take-home exam, an online exam. It's gonna be a weight of 10%, and that's gonna be on the 10th of November. In most cases, what I do is I give you the midterm on Blackboard, and I'll give you about 24 hours to complete the exam. So again, it's a take-home exam. It's open book. You don't need to really get stressed about that. In between the course, there will be some assignments, that are gonna account for 15%, and they're gonna be posted on Blackboard. Maybe not every 2 weeks, but probably every 3 weeks or so, you're gonna get a small quiz that you can work on. So as I've said, there's a term paper, and the term paper is gonna be based on a topic that the students are gonna choose, and based on that topic, I'm gonna assign some journal articles, that you can read, and then you're gonna write a summative term paper. And the summative term paper, of course, I'm gonna provide all the guidelines related to that. The summative term paper is gonna be due on the 22nd of October. That's the draft, that I'm gonna take a look at, so that I can give you some feedback on, and then you're gonna improve it, and then you're gonna submit the final term paper at the end of November, which both of them are gonna account, for 10%. That's both the draft, 2%, to make sure that I'm giving you some bit of feedback, and then 8%, for the improved final term paper. Now, remember, again, as I've said, the term paper, you need to select a topic, and the topic should be selected, by the 2nd of October, and I'm going to talk about it, in a couple of slides. What are the possible type of options or topics, that you can choose from? Now, after you write the term paper, you're going to also disseminate it in form of a poster presentation. So I'm going to give you a rubric or a template on how to make a poster. And that is really summarizing, your scientific writing now in a fairly catchy, graphical way, that captures, the highlights of what's present in the term paper, so that you can present it, often, in a public environment, so that your information, is disseminated in a summative, but very catchy way. And hopefully, the poster presentation is going to give you some better skills in terms of synthesizing and disseminating your work in a very summative, catchy way. The final exam is going to constitute 25%. There's going to be also the laboratory component, that's going to constitute 30%. There's going to be an online lab exam that's going to be just before you guys start doing the actual labs. And that's going to be posted on Blackboard. You just need to complete it. I think by the 26th of September, it's going to be posted again on Blackboard. So remember this, students must complete 70% of the lab component, to pass this course. Again, as I've said, Chem 211, it's applied analytical chemistry. It's about doing, and as such, the experiential learning that you get from the lab, becomes a very critical component of analytical chemistry. Let me very quickly talk about in the next couple of slides, the term paper, which I'm sure you guys have got, some questions about. So the term paper, as I've said, introduces students to writing, scientific writing, which opens a lot of career possibilities for you out there. If you can write properly, if you can communicate either, in written and oral, if you can communicate properly, again, it opens a lot of possibilities for you. The world, it's full about how well you express yourself. And so the term paper opens, or rather introduces you to scientific writing, but also introducing you to the ability to critically synthesize other people's work and extract the useful information out of it. And so of course, the term paper is going to introduce you to reviewing scientific literature and synthesizing the critical detail of scientific literature, and of course, summarizing it, in your own words. That's going to be the basis of the term paper, and that's what you're going to be learning out of it. And of course, it's also going to introduce you to how you cite appropriately, proper citation, of scientific literature or writing, and that's gonna be what you learn out of the term project. Now, as I've said, you're gonna select the term paper, topic by the 2nd of October, and I always like our students to work under, a cohesive theme. So the theme for this semester, all term papers are gonna be based on this theme that I'm calling wearable analytical devices for rapid environmental, food, and clinical diagnostics. And you're gonna see out there, analytical chemistry is the future of analytical chemistry is creating small devices, that can be used, for chemical detection at the point of need. Meaning, if, for example, I want to analyze, say, how much lactate is present in sweat, maybe to index sports performance, if at all I'm an athlete. You're going to see analytical chemists typically fabricate wearable devices, maybe that they can wear, such as a smart watch, so that I can, in real time monitor the amount of lactate, that is present in sweat. And that's what we are calling wearable, analytical devices, meaning they can be attached, to the sample, for real-time detection of the analyte of interest. So that's going to be the theme, for all the term paper topics that each one of you guys are going to work on. I like this quote, by this gentleman, scientist called Leighton, in analytical chemistry, 1960s analytical chemistry journal, because once said, analysis of a sample is not the true aim of analytical chemistry. It's not just analyzing the sample that we care about. For example, analysis, of lactate in sweat. No, that's not the aim. The whole goal of analytical chemistry, or the purpose of it, is to really use that data or information towards solving a societal problem. For example, in this case, to index the performance of an athlete. And to do so, well, I need to measure, how much possibly lactate, is present, in sweat, using hopefully, something like a wearable device, which is what I do a lot in my research program. In fact, I borrowed this from my research program, where we fabricate, different types of wearable analytical platforms for different types of environmental / food and clinical diagnostics applications. Let me give you very quickly examples of possible topics, that you can have, for your term project. And some of these, are from past students that we've already worked on. Most of them, of course, are somewhat, influenced by my research program here at McEwan. But students sometimes choose these and they use them as a basis for their term paper topics. A good example, Last year, I think we had a student, who worked on or who wrote about potentiometric sensors based on molecularly imprinted polymers for detection of an adulterant, called melamine that people often unscrupulously, adulterate milk with so that it can appear, to have a very high protein content. Another example, previous student has worked on, wearable electrochemical sensors, for example, to determine something like calcium, to determine glucose, to determine things like neurotransmitters such as adrenaline. We've done that in our research group, and I think a student worked on that before. Another interesting topic, fish freshness, making a sensor that can determine fish freshness in real time, using potentiometry. Another maybe good example, is a microfluidic electrochemical sensor to detect something like resveratrol. Most of you who would like to take wine, the reason people say possibly wine might be good for you is because of the antioxidants that are present in wine, red wine especially, something like resveratrol. And so a student in the past, has written a term paper, for example, on that, detection of resveratrol, using miniaturized analytical platform. Other examples, wearable sensors, for example, for COVID-19 virus. You can write a term paper on that, and a lot of work being done in that field. Maybe another example, is an inexpensive sensor to detect adulteration, in olive oil. You've got some unscrupulous vendors, who would spike olive oil, which is the virgin olive oil, which is fairly expensive, and they would spike it, with things like, canola oil, which is a lot cheaper. So can you make a sensor that can actually determine, this olive oil has been adulterated, with canola oil? Maybe another example, a chemical sensor, that can detect something like cholesterol, in meat, or even cholesterol in blood, and so on. So lots of possible term paper topics, that you can select from. And no problem, you can select, from either, of these types of topics. So where the hell do I start to select, a term paper topic? Now, you can choose, the term paper topic, from my list there. However, I think the best way to select your term paper topic, is to personalize it, to what you are interested in as far as your career path, or even, societal questions out there, that capture your passion or interest. And in fact, that's why I asked you, to introduce yourselves, so that I always care about making sure your learning is personalized. So that's something like the term paper sort of connects to what you really care about in terms of the career path, that you're interested in. And so in that introduction, that is, the purpose of why I ask you guys to introduce yourself, so that as you're selecting the term paper, it's gonna align very closely, to what you're really interested in. And so as I've said, you can choose the term paper from the list that is selected here, or you can think about, just a societal problem that you really, really care about. And then you think about a wearable chemical device that can be used to measure possibly a chemical species that connect, with a societal problem, that you like to solve. If at all you struggle again, to come up with your own, project, you can choose from my list, or you can contact me and we can brainstorm, on how you can select, a term paper topic that aligns with your career interest, which is really, what I would like you guys to do, because you get more out of learning if at all it's something that you really care about. Just to select, the term paper topic by by the 2nd, of October, you get, I think 2% or 1%, out of just posting your term paper topic, on discussion boards, by the 2nd of October. But hopefully you guys, will have introduced yourself, by the 7th of September, when we have our meet and greet time together. I think this one I'm gonna discuss later on, what's gonna constitute the term paper project, but just as a summary, as I've said, you're gonna post it, you're gonna select your project, by the 2nd of October, and then you're gonna assign you an article, you're gonna read that article, and you're gonna select another article so that you have a total of at least 2 articles, and then you're gonna write, your term paper, based on these criteria. The term paper is gonna have, an introduction, an abstract, a graphical abstract, a short literature review, a justification of your hypothesis, a conclusion, and citations as well. But again, I'm gonna give you all the details as far as, a rubric, on these later on. And take note of the deadlines of when you should submit, your draft and also your final term paper after I give you the feedback. As I've said, you're gonna create a poster presentation from your term paper, and again, I'm gonna give you a template on how to do that. So the lab component, as I've said, accounts for 35%, 5% of which, comes from the online lab exam. And I've already posted, the manual on Blackboard. And so take note of when you're supposed to come into the lab. I've posted the schedule for you. Take note of when you're supposed to come into the lab on the schedule that is posted for you on Blackboard. Take note of this, the lab component for all the labs that you guys are gonna do, and I think there are 4 or 5 of them. All of them, are based on making sure that you develop a skill to generate, to do chemical measurements with precision, but also with accuracy. So you're gonna be graded based on how accurate your data is or your chemical measurements are, because that ties into how well, you are growing, as a skilled analytical chemist practitioner. So the lab component, as I've said, the labs are gonna be largely graded on accuracy. So you have to do things very carefully in terms of weighing things fairly carefully. You have to do calibration of your volumetric equipment very carefully so that your data, is gonna be very accurate, and that way, you're gonna do well, in the labs. You also have to make sure that, your calculations, of course, are accurate, and I'm gonna provide you, with the calculation tips, online. I'm gonna give you that to help you out on each of the labs in terms of how you're gonna do your calculations. But again, make sure that, you're fairly careful in terms of doing things carefully and diligently in the lab. Don't be in a rush, don't stress out, do things carefully and slowly, so that you make sure that your data is as accurate as possible, because that's what you're going to be graded on. Because the stakes are high, because assume you're trying possibly, you're given, a tissue sample, maybe from a tumor from a breast, and you're supposed to determine if that person, has got cancer or not. So the data has to be fairly accurate, because if it's not, of course, the stakes are very, very high. So that's why we make sure that analytical chemists, are trained properly so that the data they produce out there is accurate and very, very reliable. Another very important component of the labs, is documentation. And documentation is done in a laboratory notebook. In fact, a laboratory notebook, is what people say is a legal document, because whatever you put in the laboratory notebook needs to be very legible. It needs to be an accurate representation of what you did in the lab. So if at all you make a mistake, you shouldn't erase it. I should be able to see what did you initially record in your lab notebook. And if at all it is inaccurate or wrong, just underline it or just cancel it, but I should be able to see as an instructor, what did you write initially, so that we avoid the idea of cooking data. And so laboratory notebook is a legal document, and so everything that is written there, should be legible. If you do a measurement, it should be recorded fast in the lab notebook. So you cannot have loose leaf pads, that you first record and then you transfer. No, anything that you measure in the lab should be recorded accurately and without transferring, from another loose leaf piece of paper. So make sure you have a lab notebook, because you're going to also be graded, on that as well, because it's an important part of what you call good laboratory practices. And if you go to any industry out there, you're going to see that good laboratory practices, is a regulatory requirement of assessing the reliability of the data, that is coming from that particular probably industry. And that's why we really emphasize the laboratory notebook as a component of good laboratory practices. And so you have to take note of that. I'm going to send you some details later on what is required of a good laboratory notebook in terms of how you should document that. And I'm going to send you, some details later on, about that. In fact, a short lecture, about good laboratory practices as they relate, to the laboratory notebook. So these are the 5 different, labs that you guys are gonna do this semester, and I think it's already been posted also on your on your schedule, but also in the lab manual that's already posted on Blackboard. So this is how we're gonna do it. The lectures in this course are gonna be asynchronous, meaning I'm gonna record the lectures and they're gonna be posted for you, and you can view them at your own time. During the designated lecture times, which will be optional, you can connect on Blackboard Collaborate just simply to ask questions. Those times you don't have to be there. If you don't have a question, you don't have to come to the Blackboard Collaborate during the lecture times, but I will always be available Monday and Wednesday during the designated lecture hours for you guys to drop in if at all you've got questions on the video lectures that I would have posted ahead of time. So look at the video lectures ahead of time, and if at all you've got any questions, I'm gonna be available during the designated lecture hours. Well, those times are not mandatory. I strongly encourage you from time to time log in so that we can have discussions, engagements on what's going well, what can be improved on, what are your questions, what are you struggling on, and so on. But also importantly, so that you can also connect with your peers as they ask questions, so that we can have a learning community, even as we do an online course like this, particularly the lecture component. So see you in the meeting, greet and meet on the first lecture, designated lecture time at 12:30.